New to the Holland College Prince of Wales campus as of 2011 is the Centre of Applied Science and Technology, or CAST building. Incorporated into its design are many renewable energy sources, from a solar wall to preheat fresh air and photovoltaic solar panels generating renewable energy from the sun. The building also incorporates a geothermal system for heating and cooling the building. Buried beneath the courtyard and under the bike racks are 24 boreholes. Each borehole descends to a depth of 500 feet below grade. Here you can see how the boreholes are laid out with a 50-50 mix of propylene glycol and water. In heating mode, when the air temperature in the building is cooler than the underground temperature, the water glycol mix transfers heat into the building through heat pumps. In cooling mode, the opposite occurs as the building's air is warmer than the underground temperature. The heart of the system is the building's mechanical room, and I, Dave, will guide you through its basic operations.
So welcome to the mechanical room for the geothermal system, also known as the ground source heat pump. What you see right here is where the 24 boreholes shown earlier emerge into the building. This top header is what's being returned back underground or rejected back underground. Could be heat, could be cool air, depending on which mode we're in. On the bottom here, we have the supply coming into the building. From there, it's going to fall down into here. So from there, it goes up into this pipe here where it makes this elbow joint. As you can see here, we have a temperature gauge readout. Now that just shows us the temperature coming from underground. If we're, let's say, in heating mode, where the air temperature in the building is cooler than the underground temperature, then this is going to be supplying the building with heat. Vice versa typically would happen in warmer temperatures like the summer. Typically the temperature is not going to dip below 6 degrees. Now that's because it's the boreholes are all located below freezing point, so you're not going to have that low temperature anywhere lower than that. So from there, follows this pipe along here. It goes down exactly where the arrows state, and it's going to go down into a variable pump drive system. So right here are the brains of the operation for our variable frequency drive pumps. Both these are the controllers that operate the pumps themselves. So from here, an operator can come in, either shut them off, turn them on, monitor their usage. This one's the primary one, this one's a backup. It's hardly ever on. As previously mentioned, the variable frequency drive system that you can see right here acts very much like a light switch dimmer that you'd have in your house, so it can balance it out, saves power as well. So the fluid passes through that and it gets pushed up into this pipe here where it continues on, and it's going to go into one of our many heat pump systems supplied in the building, and I'm going to take you over here and I'll show you one of those right now. So above me is one of the many heat pumps that the geothermal system supplies to. You can see here we have the supply line and the return line. If you follow the supply line, it's going to go into the heat pump system, and from there, whatever heat was collected, it's going to be pushed through in what we call a forced air system. That's going to supply the building with heat. Anything excess is going to come back out through the return and later return, and that's going to go back, continue on back to the top header that you saw at the very beginning of the video. So what we have here is the thermal expansion tank for the ground source heat pump system. In the event that there might be some sort of thermal expansion that occurs because of the fluctuating temperatures either from the building or underground, then this will compensate for anything that gets blown off. What we have here is the refill for that. So let's say that they need to refill it because that blew off. So you can grab the liquid right from here in the glycol can, go back and follow that pipe, and go right back into the system again. So what we have right here is the heat exchange backup system for the ground source heat pump system. In the event that demand for heat can't be maintained by the ground source heat pump, it's actually yet to happen, but in that event, that glycol mixture can come right into this heat exchanger, and from here, the heat exchanger is supplied heat from our district heat supply system, and you can see that loop happening right here. So from there, glycol goes through here, being preheated by our district heat, goes up into this pipe over here, and continues on into the system where it goes back to the heat exchangers and continues to provide the building with heat.
And that's the basics of a ground source heat pump with geothermal system. Thank you for watching.